The halogens are 5 non-metallic elements found in group 17 of the periodic table. The term halogen means salt former, and compounds containing halogens are called salts. As expected, these elements have certain properties in common. They all form diatomic molecules, and they all form negatively charged ions. All halogens have 7 electrons in their outer shells, giving them an oxidation number of -1. The halogens exist at room temperature in all 3 states of matter: solid, iodine and acetine, liquid, bromine, and gas, fluorine and chlorine. As seen in the graph, the atomic radius increases as you go down the group. This is because the radius of an atom is governed by the number of layers of electrons around the nucleus and the pull the outer electrons feel from the nucleus. When comparing fluorine and chlorine, it is clear to see that the outer electrons feel a net pull of 7+ from the nucleus. The positive charge on the nucleus is cut down by the negativeness of the inner electrons. This is equally true for all the other atoms in group 7. The outer electrons always feel a net pull of 7+ from the centre. The only factor which is going to affect the size of the atom is therefore the number of layers of inner electrons which have to be fitted in around the atom. Obviously, the more layers of electrons you have, the more space they will take up. That means that the atoms are bound to get bigger as you go down the group. The tendency of an atom to attract a bonding pair of electrons is the measure of electronegativity. Electronegativity falls as you go down the group. The atoms become less good at attracting bonding pairs of electrons. In the 8-group system, group number designates the number of valence electrons. The valence electrons, which occupy the highest energy levels of an atom, are the electrons that bond one element to another. These are often referred to as the outer shell of an atom. Electron configuration is one of the ways halogens can be defined. All have 7 valence electrons. Because the rows in the periodic table indicate increasing energy levels rise as one moves up the list of halogens. As you go down group 7, the atoms become larger and the highest occupied energy level becomes further from the nucleus. It becomes harder to attract and gain an electron the larger the atom becomes. The more difficult it is to gain these outer electrons, the less reactive a halogen is. For example, chlorine is less reactive than fluorine because the outer electrons in a chlorine atom are further from the nucleus than the outer electrons in a fluorine atom. It is harder for a chlorine atom to gain an electron than it is for a fluorine atom. As you go down the group of the halogens, atom size increases. As a diatomic molecule, fluorine has the weakest bond due to repulsion between electrons of the small atoms. Due to increased strength of van der Waals forces down the group, the boiling points of halogens increase. Therefore, the physical state of the elements down the group changes from gaseous fluorine to solid iodine. Due to their high effective nuclear charge, halogens are highly electronegative. Therefore, they are highly reactive and can gain an electron through reaction with other elements. Halogens can be harmful or lethal to biological organisms in sufficient quantities. Halogens are extremely reactive elements because they need one more electron to gain a full octet of valence electrons, whereas the noble gases are extremely unstable because they already have their full octet. The octet rule states that all elements tend to react in such a way to get a filled valence shell of electrons. Anything that makes this happen is favoured, and anything that keeps this from happening is not. Halogens are reactive oxidizers. They're typically diatomic. They may be at any of 3 states of matter at room temperature, and they basically react with almost anything. Noble gases are gases that don't react with much, except under very unusual circumstances.